Swayam Prabha. Digital India. Educated India.
Welcome to the DTH sponsored course on micromachining. Today I am going to discuss very important section of this course, last two lectures, that are sustainability issues in micro manufacturing part 1. Here in general I will talk about micro manufacturing, but I specifically will discuss micro machining processes with reference to sustainability issues, and this will take 2 lectures, and the second lecture will be the last lecture of the course. Acknowledgement. Lecture notes of Professor Anshudhar Jayal, IIT Ropar. Again, chapter written by Professor Anshudhar Jayal on sustainability issues in micromanufacturing in the book on Introduction to Micromachining, and very important information from Professor Ravi Shankar et al. Chapter on sustainability issues in advanced machining processes, and this is very important chapter written by Professor Ravi Shankar and his colleagues. Organization of the talk: 2 major issues and definition of sustainable futuristic manufacturing, sustainability evaluation parameters, mechanical advanced machining processes and sustainability issues, then thermoelectric advanced machining processes and sustainability issues, what has been done in sustainability issues, that we will discuss at the end of this lecture, and conclusion. 2 major issues and definition of sustainable futuristic manufacturing, and we will discuss it with reference to both macro as well as micro manufacturing, but the emphasis will be on machining processes. 2 major issues of futuristic manufacturing. First one is challenges in miniaturization, micro manufacturing, and second is green manufacturing or sustainable manufacturing. This talk is centered towards these 2 issues, and emphasis will be on engineering technologies in green manufacturing, macro, meso, micro, nano. So I will not be centering just only to micro, it will include all the 4. Advanced materials for a greener world, they are being developed, and emphasis by different countries is being given on advanced materials for a greener world. Why miniaturization? When we talk of micro and nano manufacturing or sub nano manufacturing, there is definitely a miniaturization. Why do you need miniaturization? This slide is repeated. I have discussed it while dealing with micro machining other issues also, but this is needed here because less material consumption during manufacturing, low energy for device excitation, lightness and portability, increase of selectivity and sensitivity, and cost performance advantages when we go for miniaturization. Hence, micromanufacturing has received a great attention of researchers in the recent years. When I say manufacturing, micro manufacturing, it includes all manufacturing processes, including micro machining, micro casting, micro welding, micro forming, etc. Nowadays, it is getting a lot of publicity and attracting both venture capital and federal research support. Federal, I mean in context to India, it is central government research support. It has also opened up various kinds of new interdisciplinary research areas. Sustainable manufacturing, creation of products employing the processes that are energy conservative, non-polluting, natural resources are being used, economically sound, and also safer for the employees, communities and consumers. Last point is also very important, that the sustainable process should be safer for the employees, communities and consumers, all the three partners. When applied to machining, it refers to making of products, components with the aid of subtractive processes. Subtractive processes is or are machining processes, using a machine tool for creating the features and surfaces in a way that it conserves and minimizes energy besides being non-polluting. So, we will emphasize on energy consumption in different kinds of the micro machining processes. We will see in the following slide. Factors involved in a sustainable machining process. You can see here, this is the sustainable manufacturing machining processes. Now, factors: machining cost, power consumption, waste management, very important waste management, operational safety, safety for all, operators, surrounding people working over there, personal health, because health is affected in many machining processes and care should be taken over there, and then environmental friendliness of the process, that is also very important, because you can't take the risk of polluting the environment. Many concerns related to the environment, society and economics in different engineering fields are there. Paid attention to increase productivity, product quality as well as tool life, and to decrease production cost, because last is also equally or rather very important aspect, that production cost should be minimum possible. It is beneficial to the consumer as well as to the producer. Machining sectors have not paid enough attention to limit the environmental and health issues, and both are very important. Majority of the metal processing sector use at least one type of machining process. In most of the industry, one or other type of machining process is used in some form or other. It may be traditional or it may be advanced machining process, and they are extremely popular on the shop floor, because for making any product you need these processes. Capable to produce intricate geometries, excellent surface finish and tremendous accuracy that other processes cannot readily produce, because machining processes are very commonly used, either traditional or advanced, because they are highly capable for producing accurate miniature product, useful for both small scale and large scale manufacturing. Machining creates a great deal of waste. This is another very important unfavorable point with reference to especially traditional machining processes. Solid, liquid and airborne particles that are hazardous for the workplace, safety, health and environment. So, this machining waste has to be minimized and it has to be taken proper care so that it does not affect the environment, it does not affect the surrounding people and the operator, as well as equipment also. Machining uses considerable amount of electricity, a concern for the environment. Increased government restrictions, environmental and health risks connected with the machining operations have led to higher processing cost. Governments and world leaders are advocating for green and sustainable manufacturing initiative. All the governments throughout the world, they are concerned about green manufacturing. We will see it in the following slides. Researchers, scientists and engineers, all of them have responsibility to make manufacturing processes as green and sustainable both, to safeguard the present and future generation in general, and this earth in particular. This is very, very important, and it is a great danger to this earth because of these problems. And as we will see, manufacturing contributes maximum to the pollution, to the environment unfriendliness and other issues. Sources are here, Rajmohan and Zhang Jun et al. You can refer them. Sustainable manufacturing definition and scope. There is no definite definition of sustainable manufacturing, but people have defined them according to their functions and convenience. The most well-known definition of green manufacturing came in the year 1987. Meeting the needs of present, very important, meeting the needs of present without compromising the ability of future generation to meet their own needs. This is very important. You should not play with the environment so that your future generation suffer to a great deal. So you have to take care of the interest, the benefits of your future generation, not only your own generation. The creation of manufactured products that use processes that minimize negative environmental impacts, that means unfriendliness, unenvironmental issues, conserve energy and natural resources, are safe for employees, communities and consumers. They should be safe for all the three we have seen already, and are economically sound. They should be economically sound as well. If they are not economic, then many industries or most of the industries will not adopt them. This is what has been the definition by US Department of Commerce in the year 2009. So, sustainable manufacturing includes manufacturing of sustainable products. This is also very important. It is not only the manufacturing process should be sustainable, it is also the manufactured products should also be sustainable, because they are also creating all kind of problems if you use the culture of use and throw, which was the culture in Western world including America. Now they are also changing their thinking and they are using what is known as reuse, recycle and so on. I will show you through the figures. Sustainable manufacturing of all products. National Council for Advanced Manufacturing 2009 gave these issues. Sustainable machining is defined as the product's creation by the methods that are environmentally friendly, economically sound and safe for employees. All the three are very important. I have been emphasizing on this. Consumers, communities, as well as that conserve less energy, because if it is conserving more energy, then it is not environment friendly, because energy is also polluting the environment. Creation of the energy doesn't matter how you are creating it. I am not talking about solar energy, so don't get confused. Solar energy, wind energy do not pollute the environment, but the other forms of energy creation do pollute the environment. Sustainability evaluation parameters. What are the parameters based on which you can assess the sustainability of a manufacturing process and a product? In this lecture, a systematic review of sustainability related issues and energy consumption in advanced machining processes. These advanced machining processes such as EDM, electric discharge machining, ultrasonic machining, electrochemical machining, micromachining, etc. are also discussed. This advanced machining processes is also known as non-traditional machining processes, unconventional machining processes, modern machining processes, new machining processes. Don't get confused, they are the same except the names of the books have been different by different researchers or authors. Sustainability index is obtained from the study of relationships between the variables, between the ranges of set of values of parameters of manufacturing, cutting, because we are talking about the machining, so here comes the word cutting, and those values considered initially. So please see it carefully, very interesting and useful diagram is here. This is known as the schematic of the 6R concept of sustainability, very important. You see here, this is the reduce the size, that comes to the micro products or nano products. Recycle the products which are used once. Don't go to the culture of use and throw culture which was popular in Western world in the past. Now they are also recycling it. Remanufacture the products, redesign them such that they consume minimum energy, minimum material, minimum labor, and they pollute minimum to the environment. So remanufacture these products, redesign them, recover and reuse them. So these are very 6 important issues for sustainability. There are various types of advanced machining processes with reference to which I am going to discuss this issue, and they are mechanical type advanced machining processes, thermal type advanced machining processes, electrochemical and chemical type advanced machining processes, and then related sustainability issues. Some of them I will discuss in this lecture. Sustainability evaluation, how to quantify the sustainability score of different options. This is very important, because unless you have the quantification, you cannot say that this process is more environment friendly or this process is more sustainable compared to other one. No, and this is all qualitative. Qualitative doesn't work in the science or the research. You have to quantify it. Example, paper versus plastic bags. So paper is biodegradable theoretically, plastic is not biodegradable. So there is big problem in all the countries, the pile up of plastic bags and plastic material which are not biodegradable. So it is really become a big issue in the whole world. 50 years back it was not a problem, because most of the things were being made by paper only. Both recyclable, because we in India don't use and throw once, rather we try to recycle it as much as possible. Same is true with the paper bags and paper products also. However, percent recycled depends on segregation and collection. Paper bags may be used 1 or 2 times before tearing it, and that is a common practice we all know in India. Plastic bags could be used again and again, dozens of times, provided you are willing to do so and you are using it carefully. But unfortunately, most of the people in our country also, they don't use it many times. They use it once or at the most twice and then throw it out, and that is very, very undesirable. This annual consumption of paper bags would be orders of magnitude more than for plastic. More material consumption and corresponding manufacturing emissions will be there. So it is not that using paper alone will solve the problem, because you are spending lot of energy in manufacturing the paper and you are using it once or twice. So if you are using dozens of times these plastic bags, they are more economically and environmentally better. Transportation cost would also be higher for paper bags. LCA, life cycle assessment, LCA should be used to systematically quantify all the inputs, materials, energy and outputs, emission to air, water, soil, etc. that occur over the life cycle of a product. Material extraction and primary processing, manufacturing, use, post-use, end of cycle, means the life of the bag or the paper or whatever product is there, that is there, and summarize the associated environmental impact. This is very important. Unfortunately, researchers and scientists don't pay much attention to the environmental impacts of the product they are suggesting, they are researching, they are finding out. LCA is life cycle assessment. I have used the word LCA somewhere. Sustainability issues in micromanufacturing. Miniaturization is not necessary environment friendly always. You can see here important graph. This is the log 10 mj per kg. Now this is the steel, this is aluminium. Specific material production energy taken by these materials. Steel is this much, aluminium, then polysilicon, wafer silicon, much higher energy per unit mass, and then nanotube, they are taking maximum energy in production. They are nano in size. So miniaturization doesn't mean that they are consuming less energy. Here you can see as the size is decreasing, the energy consumption is increasing substantially. Minimum size, nano size, and that is taking maximum energy, and while in case of steel etc., these are normally macro size or meso size, they are taking least energy per kg production. So you can see here, and this is another specific resource consumption and related life cycle impacts. You can see here kilogram per 200 millimeter wafer, electricity, elemental gases, specialty chemicals, energy is this much, and water is this much. So lot of resource consumption are there, and especially we should not assume that miniaturization will solve these problems. Sustainable micromanufacturing strategies. What to do next? In response to the above mentioned issues we have discussed in few slides, different countries' governments are making various policies, but outcome is not with expected results. Outcome is not very encouraging, because reason is simple, that manufacturers in those countries are not strictly following those norms, rules set for green manufacturing. What are the main solution strategies available then? These strategies are very important, and in my opinion, all the countries, industry, users, they can implement it. Process optimization to reduce energy consumption and life cycle impact. This is very important. Whosoever is making, in wherever they are making, they should optimize the process so that they take minimum energy consumption in making a product. Second, again very important, facility upgradation to reduce energy consumption. These are small points, but they make lot of difference in economy as well as environment. Improved exhaust system design to allow the use of reduced air flow, higher performance air filter, because all of them are going to consume the energy, and whatever energy you are consuming, it is going to pollute finally the environment. Higher efficiency variable speed drives, again see very simple thing, but they make the difference. Higher speed variable speed drives for fans, chillers and recirculators. All the time you need not to run your fans at the full speed. Sometimes you need minimum one, sometimes you need middle one, sometimes you need maximum. So use it accordingly, and your fans should be efficient and properly maintained. Higher efficiency motors, pumps, etc. These are very simple things, but they make a difference. Reduced clean room size, because energy consumption in clean rooms is maximum, tremendous energy consumption. So they should be clean, and you should have minimum requirement of these clean rooms in manufacturing. That is more compact layout and heat recovery systems should be there. Results of facility upgradation can be quite dramatic. Facility upgradation help in sustainability. Actual benefit from manufacturing varies with product type. It also depends on availability of more energy efficient technology. You should evolve the technologies which are more energy efficient. If they are more energy efficient, their cost will be less, and a life cycle also may be high if you do proper research. Percentage life cycle energy savings by choosing to remanufacture, reuse or replace with new for 25 different product cases. This research was done by this gentleman. You can see here. You see, this is the percentage life cycle energy savings is there for 25 products. So you can see here laptop 2005 versus laptop 2001. There, because as the technology is improving, your energy consumption in the product may reduce if it is properly designed, and your efficiency may be more. So you can see here in the laptop 2005 and laptop 2001, there is saving of around 50% of energy. CRT monitor 2005 and 2001, there is saving around 27%. So technology should help in reducing the energy consumption. They are indirectly helping the environment. And you can see here desktop control unit 2005-2001, you are able to save 23%. Like here LCD versus CRT monitor and laptop versus desktop CRT monitor, so there is an increase in 170% and 40. So all this depends upon, nowadays memories are going very high and all those things, requirements are there. So it depends upon also what is your requirement and how those particular laptop, desktop or mobile have been designed and fabricated. Because you cannot you cannot compromise with your requirement also. Just like washing machine front load, again washing machines are nowadays requiring more energy because design and your requirements. Surface texturing to enhance the performance of a single point cutting tool. Single point cutting tools are very commonly used in different kinds of the industry. So let us see how to enhance their performance. This is, you can see here, this is a single point cutting tool. This is the secondary zone, this is the chip, this is the tool, effective angle, and primary shear deformation zone is there. This is secondary shear deformation zone. Now schematic view of an orthogonal cutting operation is here. Now here it is the rake face and this is the flank face over here. Now some recent studies have investigated the effect of texturing on rake face and flank face of the tool. Now when you are texturing these rake face and flank face over there, the contact area with the chip or the workpiece surface is reducing, and if contact area is reducing, then total force acting on the tool will also reduce, and it will enhance the life of the cutting tool. So encouraging results with reference to tool life. Tool life is increased with textured tool. Flank surface is in contact with the newly generated machined surface, that is this machined surface. This is the newly generated machined surface and this is the flank face over here. Hence it has a strong influence on machined surface integrity and surface life, because total contact area with the machined surface of the flank face of the tool has reduced substantially due to micro nano texturing. Then flank face texturing enhances machining performance by decreasing tool workpiece contact area. Texturing significantly lowered machining forces, as I told you just now, at higher cutting speed and lower feed. Texturing significantly lowered the surface roughness, which is our requirement, because we normally want good surface finish of the machined workpiece at lower feed. So what I am trying to tell here is, you can make a process sustainable by changing the technology, by changing the cutting tool and other conditions. Optimization is the best, one of the best things. Sustainable micro manufacturing strategies. Texturing of cutting tools flank surfaces for enhanced workpiece surface integrity through mechanical micro machining. You can see here, this is the workpiece RA value, that is the surface roughness value, and this is the feed rate. Now you can see here very high RA value, that is rough surface, low and still lower, and here you can see this is the unground, red is unground, texture 1, texture 2. So this is the unground surface which is giving very high RA value in rough surface. This is the first type of ground, comparatively very low surface roughness, and second type is still lower surface roughness. So what kind of texture you are creating, that also makes a difference, and that controls the surface roughness value. You can see in all the three cases, and it is also a function of feed rate. At different feed rate, this nature is to some extent changing. As you can see here, texture 1 is giving better surface finish than texture 2. Here texture 2 is giving better surface than texture 1. So one should really seriously consider it, because this is the process which is maximum used on the shop floor, maybe drilling process, maybe turning process, maybe milling process, maybe facing process. In all the cases, you can have the texture tool to enhance the process performance and have more sustainable machining process. Advanced machining processes, we are going to, as I mentioned to you in the beginning, I am going to emphasize on advanced machining processes, mechanical type, thermal type, electrochemical and chemical type advanced machining processes, and sustainability issues. Let us quickly see mechanical advanced machining processes and sustainability issues. Abrasive jet machining, AJM, process and sustainable issues, very important. Various types of abrasives such as silicon carbide, silica, sand, olivine, aluminum oxide, garnet, etc. are commonly used in AJM process, which is used for macro machining as well as micro machining. Since it is used for both all these processes, so I am not deliberately telling as micromachining specifically. Environmental and health hazard issues in AJM, the particles of the hazardous elements being cut like cadmium, zinc, arsenic, mercury and lead can damage the liver due to toxicants from the same, in turn affecting reproductive system, skeletal system, kidneys, beside the respiratory system. So operator and people surrounding to the system have to be very careful so that they are not getting affected by this particular process, and there should be a proper enclosure for the whole setup so that these micro nanoparticles do not get suspended in the environment. Liver affect is there, toxicity by heavy metals, different kind, you can know, lead, chromium, etc. They are the different kind of the elements which are being cut normally on the shop floor and they affect the liver. Borne out particles of workpiece material scattered due to high velocity jet are also hazardous for the operator. So it is not only the abrasive particles but the micro nanoparticles of the machined surface, workpiece surface, are also hazardous for the operator and the people working in the surrounding areas. Prolonged working of operators may lead to inhalation of these fine particles which can cause serious hazardous respiratory and lung diseases. So one has to be really very careful about it. Dust particles of silicosis can cause scarring and stiffening of lungs. Silicone exposure can raise the risk of lung cancer over the long run. So one has to be very careful. No exposure to the silicone should take place to the operators and the people working in surrounding areas. Adequate respiratory protection equipment should be established there, essential to safeguard the workers against the atmosphere that contains hazardous chemicals when breathing in. The skin can also absorb small metal particles or abrasive particles, leading to irritation or even infection. This is quite common problem. Maintain the workstation clean. Dusty environment can result in reduced production rate and low quality products. Workers should be equipped with suitable respiratory protection equipment. This is very important and manufacturing company should take its responsibility against the environmentally contained substances that are very harmful if inhaled inside. We have seen in the earlier slide it may lead to serious diseases like cancer also. You can see here healthy lung is here and silicosis damaged lung is there. This is clearly visible, the difference in the color of these two sides of the lungs because of these particles. So silica dust particles cause scar in tissues inside the lungs, you can see over here, stiffening of lungs, and also the silica dust gets trapped in the alveoli over here. So abrasive jet equipment should be kept in isolation to avoid workers' lower productivity and higher mental or physical fatigue. Workplace conditions should be improved by proper ventilation. This is very, very important that whenever you are using these processes, proper ventilation must be there, and air which is exiting from the workplace should not be left very close to the buildings. They should be sent far off so that it really doesn't affect to the people living in surrounding areas or working in surrounding areas. Otherwise your whole activity may not serve to the extent you are intending. Air filtering setup, besides availing the appropriate dust collecting, this is very important. Proper efficient filtration should be there before you are exiting this air, polluted air in the environment. Ultrasonic machining, this is another commonly used machining process. In USM, the material is eroded due to silicon of abrasive particles with the workpiece. The slurry contains abrasive particles like silicon carbide, aluminum oxide, boron carbide, etc. Sustainability issues are ultrasonic noise, which is harmful, electromagnetic field, abrasive slurry fluids, etc., which are harmful to the environment and the operators and surrounding people both. Health issues arise with the operators working for a prolonged period in a location containing a high electromagnetic field. This is undesirable, so care should be taken. This health risk can be prevented by staying safe distance away from the source of EMF, electromagnetic field. EMF intensity drops rapidly away from the source. So this can be taken advantage of. EMF can damage various cellular structures in neurons of the central nervous system. Noise sounds harmful to the operator's eardrum and hearing if exposed for long period, because ultrasonic vibrations, ultrasonic noise is there, which is harmful to the hearing ears. It can result in acoustic trauma, tinnitus, and noise induced temporary or permanent threshold. Slurry contact leads to skin illness. Slurry of the ultrasonic machining operator should not touch by bare hands, otherwise it will lead to skin illness. Microparticle sizes less than 10 micron, if inhaled, then cause serious respiratory diseases such as asthma, chronic bronchitis, or even laryngeal cancer in long term. Installation of a mist collector or use of anti-mist chemicals in the slurry can minimize mist exposure substantially. Tinnitus, tiredness, dizziness, and nausea are common due to exposure to ultrasonic frequency. Water jet machining and sustainable issues used for cutting materials that are soft like rubber, plastic, or wood. A high velocity jet of water strikes the workpiece surface. Now this velocity of jet of water may be very high, 300-400 meter per second. Kinetic energy of water jet is responsible for the removal of material from the workpiece. However, in this particular case, as we have already seen, soft materials are being cut. Issues of sustainability, energy output and input should be maintained in the non-hazardous zone. Better to prevent the wastage than to clean up the wastage formation. In case of water jet machining, this aspect is unavoidable, and henceforth concept or reusability should be implied, and water should be mostly reused after filtration, etc., so that the eroded particles of the workpiece may be separated out before recycling the water. Sludge mixed with post machining water results in water contamination and leads to water pollution, and this should be cleaned before really recycling or throwing it out. Rust inhibitors or additives can be added, but economical aspect should be taken care of, and metal particles evolved from machining of the features may directly mix with the water jet and contaminate the surface water after disposal. Abrasive water jet machining and sustainable issues. One of the most prominently and commonly used advanced machining processes is abrasive water jet machining. A fine jet of highly pressurized water mixed with abrasive particles strike the workpiece surface at a velocity of 700 to 900 meter per second. So you can imagine or you can calculate what is going to be the kinetic energy of even micro nano abrasive particles, and it is good enough to remove the material from the workpiece surface. Such a high velocity jet results in high kinetic energy that results in erosion of material from the targeted workpiece. Material that can be machined by abrasive water jet machining are composites, rocks, ceramics, metals, etc. A dust collector system for collecting dust from the abrasives must be used for avoiding hazards on health and air pollution. This is very important as dust collector, which otherwise inhaled by the operator can cause various lungs diseases. Some of the studies revealed that recycling of the scrap of grinding can be used as alternative particles of abrasives for abrasive water jet machining. So this is economical as well as saving the material. Use of grinding wheel rejects via the process of mechanical crushing produces abrasive particles of good quality. That means the grinding wheels which are now not usable, they can be crushed and their abrasive particles can be used in abrasive water jet machining, thus confirming that the abrasives of alumina recycled could be reused successfully in the abrasive water jet machining. And nanoparticles inhalation also causes various local and systematic side effects on the health of the operator developed over the passage of time. Nanoparticles inhalation, you can see over here, delivery system characteristic inhale nanoparticles, and they are causing different kind of the problem in the lungs. So you can see therapeutic effect, toxicology effect, local effect, systematic effects. So what we have done so far is we have seen the sustainability issues, two main things, miniaturization and futuristic manufacturing, and both cases sustainability issues are there, and in all manufacturing processes sustainability issues come into picture. Here I have discussed in part 1 mainly the sustainability issues in traditional machining processes and how the sustainability issues can be taken care of. That also I mentioned, especially in case of traditional machining process, by texturing the rake face of the tool, flank face of the tool. Then I discussed the non-traditional or advanced machining processes where sustainability issues in some of the processes are really serious. So I have just mentioned to you only the mechanical type of advanced machining processes like abrasive jet machining, ultrasonic machining, water jet machining, abrasive water jet machining, where different types of sustainability issues are there, they should be taken care of. And main thing is that whatever equipment you are using, they should be maintained and kept at the maximum efficiency if you really want to minimize the energy consumption, because energy consumption is one of the major factors which affects sustainability issues. Now in the second part of the lecture I will discuss with you thermal advanced machining processes, chemical and electrochemical advanced machining processes, and then I will discuss other issues of this particular process. Thank you very much.